Welcome back to our channel. Today we will discuss about limits of trigonometric function. Here we have some of the limits of trigonometric functions. There are three formulas. One, limit x tends to 0 sin x by x is equal to 1. Second, limit x tends to 0 1 minus cos x by x is equal to 0. Third, limit x tends to 0 tan x by x is equal to 0. Now, find the proof of these three formulas by using sandwich theorem. Sandwich theorem is explained in the previous video. Now, let's discuss the proof of the first equation. Limit x tends to 0 sin x by x is equal to 1. Let's use sandwich theorem and derive this formula. Now, we have to explain the proof of the first equation. Limit x tends to 0 sin x by x is equal to 1. First step, to take one circle. First step, take one circle. This is a circle. We have to take one circle. This is a circle we take. Then the radius of the circle is 1 unit. Then first we take a unit circle. That means the meaning of the unit circle is the radius of that circle is 1 unit. Clear? Let's. The center of the circle is O. First we take the unit circle and the center of the circle is O. Then OA is the radius of the circle. Then take any point C on the circle, then OC is also the radius of the circle. OA and OC are the two radius of the circle. So we say that OC is equal to OA. Why? OC and OA are the two radiuses of the same circle. Now, is it clear? This is first we have to take the unit circle. Unit circle means the radius of the circle is 1 unit. Then O is the center of the circle. OA is A and C are any two points on the circle. Join OA and OC. We got two radiuses. What are they? OA and OC. Both of them are equal since both of them are the radius of the same circle. Is it clear? Next, draw a tangent at the point A. This is A here. Draw a tangent at the point A. Draw a tangent at the point A. We have to draw a tangent at the point A. So, then AB is that A. This is the tangent here. Now, then extend the line OC. We have to extend the line OC near to the tangent. So, both of them meet at the point B. Is it clear? Next, draw one perpendicular from the point C. This is the perpendicular drawn. That perpendicular meet OA at C. So, this is a perpendicular. So, this is 90 degree. The angle. Sorry, this is not C. This is D. This perpendicular meet OA at D. Is it clear? Now, let's join C and A. Join these 2 points by a straight line. This forms our diagram. Then, using this diagram, we can derive limit x approaching to 0 sin x by x is equal to 1. Is it clear? I'll explain it in detail. Take one unit circle. Take one unit circle. Its center is O and A and C are 2 points on the circle. Then join OA and OC. Join OA and OC. Then draw a tangent at the point A. Then now extend OC near to the point B. That point is known as B. Extend OC near to the tangent. Both of them meet at the point B. Now, draw a perpendicular. That perpendicular meet OA at D. Draw a perpendicular from the point C. That perpendicular meet OA at D. Now, join A and C. Is it clear? Now, join A and C. Now, look this diagram. This is a unit circle. Center O. A and C are any 2 points on the circle. Join OA and OC. OA and OC are equal since these two are the radius of the same circle. Now, draw a perpendicular at A or draw a tangent at A. Draw a tangent at A. Then now extend OC near to the tangent. Both of them meet at B. Then draw a perpendicular at C from the point C. Draw a perpendicular from the point C. That perpendicular meet OA at D. This angle is 90 degree. This angle is also 90 degree since these are the perpendiculars. Is it clear? Using this diagram, we have to prove limit x tends to 0 sin x by x is equal to 1. So this is a circle. This is the chord. This is arc. This one is arc. Then these two lines, this are combining to this arc is known as sector. Is it clear? This one. This combining these two radiuses and this arc is a sector. Is it clear? Using this diagram, we have to prove this equation. This is a unit circle, circle of radius 1 unit. Then we have one perpendicular angle and that angle created with the x radian. This is the perpendicular angle that created. Let's draw separately. This is our OC. Then this angle created with the x-axis direction. So clear? This is our A. This angle is created with x-axis direction. So that angle lies between 0 and pi by 2. Angle AOC is equal to x radians. That angle lies between 0 and pi by 2. Since this angle is created with the x-axis direction. OC line with x-axis direction. So we have two perpendiculars. They are AB and CD. Both of them are perpendiculars, AB and CD. Then we have another perpendicular CD. Already this is AB is a perpendicular. Then that second one is CD. So angle A equal to angle D equal to 90 degrees since these two are perpendiculars. Now here join A and C so that we get so many triangles here. Is it clear? Is it clear? So take one unit circle, center O. A and C are 2 points on the circle. Join OA and OC. Both of them are equal since both of them are the radius of the same circle. Now draw a tangent at the point A. Then extend OC near to the tangent. That meeting point is known as B. Then draw a perpendicular at C. That perpendicular meet OA at D. This is a perpendicular, so this is 90 degree. This is also a perpendicular, this is also 90 degree. Then join A and C. Then this is the angle made between OC and x-axis direction. This is x radian. This x radian lies between 0 and pi by 2 since this angle is made between the OC line and the x-axis direction. So clear? Now here in this figure we have so many triangles. So clear? Then so we have to draw that triangle separately. So first one OAC. Then second one OAB. Third one this is a sector OAC. This arc combined to these two radiuses and arc. This is the sector. So we got three figures. First one is triangle AOC, second one triangle OAB, third one sector COA or AOC. So we have to observe these three figures. Which one is the largest figure? We know that triangle OAB is the largest. So triangle OAB has the largest area. Second one, sector AOC. This one has the second largest area. Third one, triangle OAC. This is the smallest one, the smaller area. Is it clear? So we know that how to find the area of the triangle. Equation is half into base into height. Then how to find the area of the sector? Area of the sector is equal to theta by 2 pi into pi r square. What is theta here? Here theta is the angle made between the two lines. 2 pi means 2 into 180, that is equal to 360. Is it clear? Theta is the angle made between these two lines. This is the sector. This is the figure having the largest area, second largest this, third largest this. Is it clear? Now observe this figure and now observe these three figures. Among these, we will write one relation. Observe these figures. Which one has the largest area? We know that this one has the first largest area. Then the sector. Then this small triangle, AUC. Now write this is in the form of a relation. Right, area of triangle AOC is less than area of sector OAC is less than area of triangle OAB. This is the relation between these three figures. This one is having the largest area, second largest, third largest. Is it clear? Now, the area, how to find the area of the triangle? Area of the triangle is half into base into height. Here, first triangle is triangle AOC. Here, OA is the base and CD is the height. Here, next one, OAB. In this triangle, OA is the base and AB is the height. In this sector, how to find the area? Area is equal to x by or theta by 2 pi into pi r square. Is it clear? Here, half into base is OA into height is CD less than here half into base is OA and height is AB. Then what is the area of a sector? Theta by 2 pi. Here theta angle is x. X by 2 pi into pi r square. What is r here? OA and OC are radiuses. Here we write pi OA square. So here 1 by 2 and OA are common in these inequalities. So we have to cancel 1 by 2 and OA. So cancel 1 by 2 and OA. After cancelling, we have remaining CD less than XOA less than AB. Is it clear? Now consider the triangle OCD. Here this is the base, OD is the base and CD is the opposite side and OC is the hypotenuse. Now consider another triangle OAB. So OA is the base and AB is the perpendicular or opposite side. Then this BO or OB is the hypotenuse. So consider the triangle OCD. Sin x equals, what is sin x here? Opposite side by hypotenuse. What is the opposite side here? What is the opposite side here? CD by hypotenuse is OC. CD by OC. Here OC and OA are equal. So instead of OC we write OA. So sin x equals CD by OA. Since OC and OA are radiuses of the same circle, both of them are equal. So from this equation, we write CD equal to OA into sin x. Now consider the triangle OBA. Here tan x equals opposite side by adjacent side, that is the base. So what is the opposite side? AB by OA. Then AB equals OA tan x. Is it clear? From the above equation, CD less than XOA less than AB. So instead of CD, we write this equation OA sin x. Then instead of AB, we write OA tan x. So this equation becomes OA sin x less than XOA less than OA tan x. Here we substitute the values of CD and OA in this equation. We got this. Then OA is common. So we had to cancel OA from all the inequality. We got sin x less than x less than tan x. So tan x is also sin x by cos x. So instead of tan x, we write sin x by cos x. Sin x less than sin x by cos x. So dividing these inequalities by sin x. So sin x becomes sin x by sin x. X becomes x by sin x. So sin x by cos x becomes sin x by cos x into sin x. Sin anything by that number that is equal to 1 less than x by sin x less than. These two get cancelled, then 1 by cos x. Now take the reciprocal, we get 1, 1 greater than, take the reciprocal, the inequality will change. Sin x by sin x becomes sin x by x greater than 1 by cos x becomes cos x by 1. Then we can write the inequality in this way also. Cos x less than sin x by x less than 1. Here we need to prove limit x approaching to 0 sin x by x is equal to 1. For that, we apply the sandwich theorem. What is sandwich theorem? We know that f of x less than or equal to g of x less than or equal to f of x. Then the limit of f of x and h of x are same. Then we apply that limit to the middle function. Limit x approaching to a f of x equals limit x approaching to a h of x equals L. Then limit x approaching to a g of x is also L. Here g of x lies between f of x and h of x. And the limit of f of x and h of x are equal, no need of calculating the limit of g of x directly. By referring the limit of f of x and h of x, we can conclude that limit of g of x is also that value. That means if limit x approaching to a f of x equals limit x approaching to a h of x equals L, then limit x approaching to a g of x is also L. This is known as sandwich theorem. Applying sandwich theorem, we prove the result. So cos x less than sin x by x less than 1. Here, this is our f of x and this is g of x and this is h of x. Applying the sandwich theorem. Then, finding the limit of these two functions and both of them are equal, then that limit is applicable for the middle function, that is g of x. Then applying the limit to this inequality, what will we get? Limit x approaching to 0, cos x is less than limit x approaching to 0, sin x by x less than limit x approaching to 0, 1. Then calculate the limits of these two. Limit x approaching to 0, cos x equals, applying the limit directly, that is cos 0 that is equal to 1. Limit x approaching to 0, 1, that is equal to 1. So 1 less than or equal to limit x approaching 0 sin x by x less than or equal to 1. By sandwich theorem, we conclude that limit x approaching to 0 sin x by x is also 1. In this way, we can derive this formula. This is one of the formula of trigonometric function. What is that? Limit x approaching to 0 sin x by x is equal to 1. Is it clear? Next, we have to derive the remaining two formulas. Second one, limit x approaching to 0, 1 minus cos x by x is equal to 0. Limit x approaching to 0, 1 minus cos x by x equals limit x approaching to 0. What is 1 minus cos x? That is 2 sine square x by 2 by x. What is a square? A square means a into a. So sine square x by 2 is sine x by 2 into sine x by 2. So 2 sine square x by 2 can be written as 2 into sine x by 2 into sine x by 2. So we know that limit x approaching to 0 sine x by x is equal to 1. X approaching to 0 sine x by x equal to 1. So here we apply the first trigonometric formula. In this case, we convert this equation into the form of this. How to convert? Here sin x by 2 is there. If we want to apply this formula, here also we want x by 2. Here only x is there. So we want to multiply and divide by 2. So limit x tends to 0, 2 into sin x by 2 into sin x by 2 by x into 2 by 2. 2 by 2 is 1. So this 2 we write here and this 2 keep it here. So the equation becomes limit x tends to 0, 2 into sin x by 2 into sin x by 2 by x by 2 into 2. This 2 can be written as into 1 by 2. So this becomes limit x by 2 tends to x tends to 0, then x by 2 is also tends to 0. Then instead of this we write x by 2 tends to 0. 2 into sin x by 2 by x by 2 into sin x by 2 into 1 by 2. These 2 and 2 get cancelled. Then we got limit x by 2 tends to 0 sin x by 2 by x by 2. Applying the limit separately. Limit x approaching to 0 sin x by 2. What is that? This is limit x approaching to 0 sin x by x is equal to 1. So instead of that we write 1. 1 into sin, apply the limit directly, sin 0 by 2. That is 0 by 2 is 0. Then 1 into 0, that is equal to 0. So limit x approaching to 0, 1 minus cos x by x is equal to 0. This is the proof of second trigonometric function. Next, we have the third trigonometric formula. Limit x approaching to 0 is tan x by x equal to 1. So limit x approaching to 0, tan x by x equals limit x approaching to 0. Instead of tan x, we write sin x by cos x by x. Limit x approaching to 0, sin x by cos x into 1 by x. This x can be written as 1 by x. So here we write x here and cos x here. So limit x approaching to 0, sin x by x into 1 by cos x. So here apply the limit separately. Here we use the algebra of limit. So limit x approaching to 0 sin x by x into limit x approaching to 0 1 by cos x. So what is this? This is our first trigonometric formula. We know that the value is 1. 1 into, here apply the limit directly. 1 by cos x becomes 1 by cos 0. We know that cos 0 is 1. So 1 by 1 that is equal to 1. So this is 1. So limit x approaching to 0 tan x by x equals 1. This is the proof of third trigonometric formula. We conclude that limit x approaching to 0 sin x by x is equal to 1. Limit x approaching to 0 1 minus cos x by x is equal to 0. Limit x approaching to 0 tan x by x equal to 1. This is how we prove the trigonometric formulas. This is how we prove the limits of trigonometric formulas using our diagram. Is it clear? Any doubt? Thank you.